What is 3/5 plus 2/7? This represents a common misconception many kids have where they begin to add fractions and they look at the numerator and they add the numerator just as they would whole numbers. And so we see 3 plus 2, they get 5. And when we look at the denominator, we see that when the students add 5 plus 7, they get 12. And so this shows that they focus on whole numbers, and we know that is incorrect, as we want the kids to understand that a fraction has value, and that is what many of them are missing. So before they begin to add or subtract fractions at all, they need to understand individually what one fraction, what the meaning of that, interpret that one fraction before they begin to add, subtract, or perform any operations to it. So we're going to look at the meaning of 3/5 first. What does that mean before I start doing anything to it, before I add anything to it? So I know that 3/5 is less than a whole. These are not whole numbers. These are parts of a whole. These are fifths. And I know that 3/5 is going to be greater than 1/2. And I know that 3/5 is greater than 1/2 because 3/6 is 1/2. And 3/5 are greater than that. Now we're going to look at the second fraction, and we automatically see that there we have sevenths. And in the first fraction, we had fifths, and we see that they're different sizes. So there are different number of parts in the whole, different size parts in the whole for each fraction. So that tells us that we can't just add those the way that they are. But back to 2/7, we know that 2/7 is going to be less than 1/2. And the reason that we know that is because if we think of 1/2 as 2/4, we know that 2/4 is greater than 2/7. So that helps students when they have to determine if an answer is reasonable or not. So we have 3/5, which we know is greater than 1/2, and 2/7, which we know is less than 1/2. So the sum is going to be greater than 1/2, but less than 1/2. So we know that is our best estimate. And when we get our answer, we can check it and see if it's reasonable. So instead of looking at fifths and sevenths, we'll find a common denominator, which shows that there will be the same number of parts in the whole, and then use it to find equivalent fractions. The common denominator here is 35. So instead of looking at fifths, we're going to look at 35ths. So we're going to multiply by 7/7 and get 21 35ths. Now we're going to look at 2/7, and instead of looking at sevenths, we're going to look at 35ths. Multiply by 5/5 and we get 10 35ths. And we're going to use those equivalent fractions, which is the same value as what we originally started with. It's just now we have the same number of parts in the whole, and we have 31 35ths. And we think that is correct because of our estimate. 31 35ths is greater than 1/2, but less than 1/2. Kids need to understand that when they have the same number of parts in the whole, that means that the sizes of the parts is the same, so they can add them now. They should understand why it works, why they have that common denominator, and use it to find equivalent fractions. This will help the students to understand what it is that they're doing and why they're doing it. So when they look at any fractions, they should be able to tell you first off, are the sizes of the parts the same or different, and then determine if they need to find common denominators and then find equivalent fractions to perform a calculation.